we can begin. I mean, I hope this is a small class. We limit it to maybe 10.
Maybe convenient client presentations.
Okay, so yeah, so last time you installed Qiskit. Um, yeah, so this is a class we're going to be interactive. So you bring your laptop and maybe we'll run something. Yeah, we did the Jupyter demo last time. Yeah, there's documentation, help you to install, and there's video. You saw it last time. Well, maybe we'll cover some Python basic programming, and we have experts actually here. So, maybe you could download. I upload a few notebook. If you want, you can download. But this is really just refresh your memory on Python. Course website. Yeah, so I list a few resources for Python. If you go to this page, there are many resources you can learn Python. So, but I think most of you know Python. Yeah. And actually, I found a very nice book, a quite small book. This is a book. It's Learn Python in 1 day, which we're going to do today. See if we can learn Python within 2 hours.
There's only $3.
Yeah, so you can actually purchase less than $4, and there's a workbook with that. Yeah, this is the book that I used last summer to teach my son Python. But this is actually another book. This is a Python programming numerical method guide for engineers and scientists, maybe more professional. It's written, I think, maybe in Berkeley, right? Berkeley Python numerical methods. Maybe it's associated with a course. But in the first half, it's covering basic Python. But that's probably the universal you can get from anywhere. There's also Python tutorial. Here you can learn a lot of examples from here, and then there's some small tests, quiz you can do. If you also Google YouTube, there are a lot of really tutorial, a few hours, 4 hours, 5 hours. Yeah, but we're not doing too much heavy programming. So what I'm going to do is, okay, this is the penny line. We'll go to that later. But let me go back to this one. Okay, so this one is a notebook you can download. Basically from that Python book, Learn Python in 1 day. I copy some of the example. there's
I can use one for junior.
that?
I can make one for junior.
Yeah, okay, but we don't need Julia, of course. Maybe in the future we talk about other platform they might use Julia. For example, Qera they use Julia, but they also have Python. But this semester we probably won't cover that. Yeah, what is Python? Yeah, it's a high-level programming language from this python.org website. Says Python is powerful, fast, play well with others. You can easily hook up with other platform or other languages. Run everywhere. It's friendly, and it's open. So you can just play along with the notebook. You just really just press Shift and Enter and go through that and then refresh your memory. So let me ask again, who knows Python? Who is comfortable writing Python? Yeah, so most of you. So maybe I don't need to go through the detail. Right? So, well, the first thing you do in any programming language is probably print hello world, right? You can replace some of the words as shown here, right? And you can actually add strings. And of course, they are variable. That's what we use a lot, right? Solving problems, we use variable. Here's the user age. This is an assignment to a variable, and then this is an assignment of two things in one line. Has the student age and name. So it's a number, integer, and also the other one is a string. So you can ask its type, right? The age is an integer, name is a string, right? Yeah, there are many ways of printing, right? You can just print to variable and they will be separated by a space. And morning. So all these notebook are on Brightspace. You can download if you have a notebook. Yeah, all of you are registered. At least I add manually those who are not registered into the Brightspace. You can download go to the Brightspace, download the material. Right, the print function. This is probably the most raw way of doing print. You format everything on your own like this, right? With space, but you could also add using the plus to add the string, as we did. Okay, but you could also use these kind of formatting. There's a string S, there's a integer D, and these are the variables. Yeah. So just play along. And then you could also use these curly bracket, use that format. Yeah, yeah. You could also use yeah, if you this you can use \n is to switch to another line, like end of line, etc. Yeah. You can also cross a few lines by really breaking into lines. Yeah, and you can do it just like this using formatting, right? And you can enter, for example, this is the input. If you want to enter something, then you say input, and this is the message you print out. And okay, the student's name, maybe I don't know, John, 20 years old, something like that. Okay. Again, this student name is the type is string, and here the age, right? We input that it's also a string. In the previously it was integer when we assign like 10 or something, but because we use the input, so you can convert that. Like you just say integer, right? You can convert to a value, right? And you print the type. Yeah, this So you could also print, for example, the type. Yeah, so this, we add a type. You can also print the type of value. Of course, you know it's integer. Okay. Yeah. Okay, and if you have integer or you have numbers, you can just multiply them. This is a floating number, and they can multiply and compute the area, and this is how you format. You can do the formatting, like you have 2 after the point, and then your total you have 4, and you can do all these formatting. Okay. Probably you did this some other language like C or something. I didn't. And there are these basic operator, plus minus, multiplication, divide, and this one maybe is taking it. This is probably not necessarily in any other. This is like taking the integer.
It's not
Yeah,
always
the floor.
for negative number.
What is that?
For negative number,
Well, you could try. Yeah, so you need to know what exactly it's doing. So if you want to say 3 minus 2, it's minus 2. Mod, yeah, it's modular. It's a bug. It's a floor, yeah. So this is really floor. So like this divided by is minus 1.5. So taking the floor will be minus 2. So that will be a convention. Maybe in other language, you define that in a different way. So you have to know. And this is the power, like x to the y, 5 to the 2. That's 25. Okay. And you can this is the assignment. So x plus 2 would assign to the variable x. You all know this. Yeah, kind of quite basic. You can print, for example, you print y. We have y there, 2. You can say y minus equal to 2 is y minus 2. Okay. Yeah, we talk about variables. Now we talk about a list. You can put a list of things together. Doesn't to be, you don't need to have the same type. It could be different type. For example, I have a list of student score. How you access that is Python start from 0. So the 0th one will be 70. Minus is the last one. Okay. And then you can also change the value in the list. Okay, I add 2 to the second, but second you count from 0. So I add to here. I add to 60. So you can see the list changes. And you can also access from 0 to 3, but does not including 3. So 0, 1, 2. If you print that first 3 element, this is like from minus. Let me see. What is this? Minus 2, minus 1 is getting. So I guess it's from here, minus 2. Yeah. This is minus 2. So there are many ways with different order. You could go backward, I guess. Student, if you say 2 will be from the second one, which is 65, go all the way to the end. Yeah. And you can add to the list. I can add to the score, like incomplete. And I can insert in the location 1, insert score, right? I could also delete the 5th one. 1, 2, 3, 4, 5, 85 will be removed. And the next one is tuple. Tuple is similar to list, but somehow when you assign a tuple, you cannot change. So, but it's very similar, but using the circular bracket. So days, 0 1 is Sunday, but you cannot change it. If you try to change that, it will say this error. And you can also not append. Tuple is just, you just created it, just remain the same, you cannot change. I think that the next one is interesting one. It's called dictionary. It this key and the value. So you can initialize that this key and data. So there are names and maybe their age. Okay, I can also initialize like this. I use the keyword Dick. I assign John is 32, Mary is this. You can compare. They're the same. Somehow, when you type John, it would convert that to a string. Okay. So they look the same and they are the same. And how do you get the value or the data? You just say by dictionary. It's like a list, but you put in the key. So you get 24. The Peter. You can also change. You can change and change the dictionary content. You can also add. When you add, use assign something new. Julia 34. You can also delete. You can delete an item in the dictionary, right? You delete John from this. When you add, you can also use update. Even though there was not Mike here, you can still update. So if Mike was there, when you update, it would update. Okay. And you can also remove, use pop, pop Mike. So done. So of course this is probably a different dictionary because the content is different. Dictionary, yeah. One. John, Mary, and Peter, of course, is different. Okay. Yeah, if I assign my dictionary 3 is equal to my dictionary, it's actually it's not the same. It's actually not copying. It's actually a link to that dictionary. Like for example, if I update dictionary and add Mike to that, and the dictionary 3 will change because this is just the same as that. It's not really copy. So if you want really copy, you have to say dictionary copy. So it will copy the content. And when you change the content, it would not change. It would not change. For example, I pop in my dictionary, Mike. So dictionary 4 will not change. Okay. So we spent how much? 20 minutes on this almost. So next is function. You define function by saying def and then function name and anything argument that you can put in. For example, we have the area, right? And Python, you need to indent. So recognize the structure by how you indent. Okay. You can print this and you can assign. You can use the function, including the variable height and width. Yeah. Okay, so this is the function. There's also something called lambda function. This is an anonymous function. So for example, I have a string is lowercase, and I design write a lambda function. Lambda is a function, and function, this go to the uppercase. So you can just, S2 would convert the string to uppercase. I think this is, it can be anything, I guess. So this is really just something that inputs. Okay, there's one more example. Lambda function x, if positive, if x greater than 0, else negative, or else 0. So, and this is named n. So n of 7 is really just evaluating 7 into this logical expression. Okay. Okay. Conditional statement. This is like basically logical expression. Is phi equal to phi, phi greater than phi, so true and false, etc. And not equal is using this exclamation mark equal. Okay. And for 7 is not the same as 7 minus 1. And of course, this is a false statement, etc. Okay. True. You could also compare string 1 equal to string 1. If I have one more space, of course, it's not the same. Logical statement 7 greater than 8 or 7 lower than 8. There's one true statement there, so or is therefore it's true. There's one false statement in the end, so therefore it's false. Okay. Then you can use if to consider different cases. So, for example, I'm inputting, would you like to study quantum programming? Enter yes or no. Okay, so if yes, then we'll print welcome. If no, maybe next year. Else, enter a valid. Okay, so for example, I enter yes. But because I am not entering the same string, so therefore it doesn't match this. So we go to this. So of course, if you want to be comprehensive, you have to maybe convert that to the same uppercase or lowercase, and then you compare, right? Okay, so for example, say no here. Okay. There's an inline if. Do task A if condition is true, else do B. So yeah, welcome. If input is yes, else print is here. Okay. So this is like if you want to write it really short, but you can, it's okay to expand it. But maybe some programming guru, they like to write in a neat way. For loop. So we have the student score, and we can say for score, this is a dummy variable in the list. You print the score. Okay. And sometimes you want to get the index number 0, 1, 2, and so you can use enumerate and then print this. Okay. You could also get from the dictionary. You could say for I in the dictionary, you can print names. So when you use I would run through the keys. So in order to get the value, you have to use my dictionary square bracket key. You can also use dot items to get both key and value. and you print them. Okay. Here is just to format. So you can also say for key in my dictionary dot keys, you go through all the keys and then you can print. So I'm using the format we learned previously. To print things or run to for loop in some range, you just do for I in range 5. So we go from 0 to 4. Okay. You could also specify some range 3A, so does not include 8. Okay, you could also specify a skip 2. You could also go backward. Yeah, for loop. Okay, done with for loop. You could also do while. Of course, while you need to have a condition. If that's true, you do this. So we start counter 4. If the counter is greater than 0, then you print this, and you start decrease until it's equal to 0, so it will stop. And you can also see if the counter still has what is the value of counter. Let's see here. Because it decreased to 0, and then it exits. Okay. This is just things that we saw previously. Okay, you can force to break from a loop. For example, I add. Okay, so for I in range 6, I start with k equals 0. For each time, I'm adding 2 and print j and k until when k is 8, and I break. Break will break this for loop and not doing anything else after that.
And put the break inside of a 2 for loop.
Don't
If there are 2 for loop,
yeah,
you only break the second one.
you only break the second one. Yeah. So yeah, it will break this level. You need to have another break. Okay, continue is that you skip that. So the difference is skip that, it will continue to do the loop until the end. Right, so here 3 and 8, and then afterward it stop. But here, so I continue, so I did not print this, right? So every other time I print this sentence. Okay, so here it is. Try and accept, because sometimes you would, for example, you input something, or it's not the same type, or this is the wrong divided by 0 in this case. And we'll try this, and of course there will be a error, right? It's division, 0 division. So you can say try this. If really break, and you go to the accept. Okay, and there are a few errors like value error, 0 division, IO error, import error, the index error. For example, it's going out of range, key error, name error, type error. Yeah, this is just one example. Try input a number. This is input 1, and I convert into an integer. Enter a second number. I want to divide the 2 and to look at the ratio, but like, okay, so I could do this properly. I would input 3 and then 2, then of course it would do properly and then print the ratio. Let's see if I enter 3 and 0. 3 divided by 0 would cause the error, which is 0 division, right? And there's also, for example, enter number, but I enter A, then it would it would raise the value error because I didn't enter number, and it would immediately from here go to the except here. Okay. There's also what is unknown error? How do I get unknown error? Yeah, doesn't anyone know how can actually cause the unknown error? Some other error. Yeah, this would be just a value error. Yeah. Put what? Put a string, it would just it's a value. Oh, I mean the number too big. Okay. Could be. But I mean when you are writing program, there will be sometimes there will be errors and you want to consider all possible things to deal with. Otherwise the program would exit. Okay. Okay, this is function. We talk about function. You define a function, try except. Oh, this is the same thing. I just write as a function, and you can play with this many times. Yeah. Okay. If I do Control C, no, Control D, nothing. So I don't know how to cause these unknown error. Yeah. Okay. 0/0 will be value a division. Okay, the division. Yeah. Okay. So this is the first half of the factor. It's probably who feel that they already know everything. Raise your hand. You like you know like 80% or about 80%, 100%. Yeah, it's okay. I mean, we don't need to remember everything. We just look up. Yeah.
I think the best way of the Python is
Using.
Using it. Then
Yeah. So you just if you forget, you go to maybe I saw this in a notebook, and I go back. I think for me, I'm just collecting information. If I need to check, okay, how do I format the print? I'll go back to the notebook that I actually use it, right? Or I look up the documentation. Okay, so this is the first, and then yeah. So for this, we learn in 30 minutes. Yeah, this probably would took this. I think this took almost the whole summer for my son to go through it.
Oh, your son already did that.
But by now he forgot everything.
Yeah, that's the point. I also forgot it 3 times before I actually use it. But when I started using it, I don't think.
Yeah, so I think when I now put everything in the notebook, it's easy to play again, and then maybe easy to learn it again.
How did it actually?
Yeah. Okay, so what I'm going to do now is open the second one. I think sometimes it's good to refresh like this. And I never learned Python in a proper way, but just read other people's code, play, try, and I'm not an expert. And so this is the second half. So we'll get deeper into the function and module. You define a class. Okay. Yeah. Okay. Actually, it's now the last half of the lecture. Okay. So for example, we'll define a function that check if the number is a prime or not. Right. So you'll know how to check the number is prime. Right. Just check if it's a factors. Right. Right. And you only need to check up to the square root of that number, right? So, yeah, so this is what I do. So check number is prime. So in range 2 to the square root of that number, you try to see if that number can be divided by x. Okay. Of course, we will do more. We like waste a lot of time because most of these are not necessary. Yeah, of course. Primarily check it's a polynomial problem. I think it's polynomial. The order may be 4. For time is, say that again. No. It's not. I think that there's a mistake. I remember when I was a student, maybe graduate student, and there was a announcement of primarily tests that some people come up with a way. Yeah. I think that was a big thing in the time because factoring is hard, right? So we already learned Shor's algorithm. Factoring is hard, and but you it's prime or not, but you cannot factorize efficiently. Okay, so we define this.
What do you mean to detect the prime that factor?
Detect whether it's a prime or not. Yeah. To factorize is harder. Okay. And I don't know the algorithm, but if it is a programming class, I would assign that right after that primary test, the most efficient algorithm. But you could probably ask if you could probably ask DeepSeek, please code up the primary test. Yeah. Okay, so let's define this function. And it's important you need to add 1. Because the range, if you miss 1, it would be wrong. So, okay, so you see 49 is not a prime number, we know, right? But if you miss this +1, let's say I remove this +1, because the range, it does not include the last one. And also square root may round up. So if I do this and check whether 49 is a prime, then we say true. Because it did not check the 7th, right? You forgot to check the 7th. So when you write, it's really important to make sure. Yeah, even though it looks correct, but in the detail there's +1. That make it so that's why debugging is sometimes it's hard. Is this +1 or -1?
Right.
Yeah, because the range does not include. But also when you take square root and you round the number, maybe you will miss 1. Yeah. Okay, so that's the function. And I don't know if here I say number integer, but it does not check. So maybe Wenhan, you know, does it when I say the variable is integer, but if I do this, it's like 7.5. It won't say anything, right? It won't say anything.
So maybe yes, instance.
You have to.
Yes,
oh, you mean like it's instance.
I think there are also with non-pair, but
I think it's like 2.
Two? Okay, maybe it's 2. Yeah. No, this is better.
No, I mean, in the function.
Of course, inside the function, if of course you can inside that you can check.
I mean, this one is like a type A, so it's not exactly a type.
Yeah, that is not a constraint. That is just a thing.
It's just saying for you to see. It's not. There's no constraint.
Yeah.
There's no.
Yeah.
It's not strictly enforced. Yeah.
So you have to check the frame from.
Yeah. So this will be wrong, right? So in order for a function to be really comprehensive without no possible error, you have to check a lot of things. So this is really just a simple function, and this is wrong. It's not even an integer. So So you have to add things. This means yeah, need to add this checking. Okay, but I won't do it here. Yeah, you also know the variable scope. There's a global variable and there's also local variable, right? So for example, this meshes one here is a global variable and message two is a local variable. So outside the function, you will not be able to access message two. Okay. Yeah, of course, this will cause error. Of course, we can use the try except, right? Try bring this and then this is not defined. When you define function, you can have default value, but those values need to be to the right, like A, B, C, D, E, and then I have C, D, E is already assigned default value. So when you do this, you don't need to type input all the variables. So you don't need to assign those with default value. So 1 to 4 will be assigned 1 to A, 2 to B, 4 to C, and D and E doesn't change. You could also print this. 1, 2 would also work. Okay. And of course, you cannot just have 1. That would cause error. Okay. So just play with this. And then sometimes if you want to define functions that may have variable length of argument. So the way you do it is you use a star. Here star num. These are non-keyword variable length argument list. So this is basically like a list. You treat that as a list. So I define this. I want so this be a list, so I can just run through it and then add things together. Okay, so then I can add things that I type in argument. So just add these numbers. If I have just one, it will be just that number. Okay. This one, keyword with variable length list. This is actually a dictionary. If you have a double star, the double star will be a dictionary. So the way you retrieve information, as we saw last half, is you could use item to get both key and values. Okay. So when you input this, you could input Peter equal to 5, John equal to 7. It's like inputting item by item in the dictionary. Okay. And we'll treat that as a dictionary. Okay. Okay, so sometimes the bare Python function is not enough, so you will need to design more additional things, and you will import module or package. Right? So here we have random, and we can say I want a random integer from 1 to 10. Okay, so here I need to use random because I import that random dot this function. If I say this, it will not be defined. Okay. In order for that, you need to say from random import that, then it will be defined. Okay, let me try this. Okay, in order for this line to work, you have to say from random import range, and you can say that. Okay. If you import package to use the function, you still need to use package or module dot the function. Okay. Okay, I did this here. Okay. Any questions so far? Okay, so this is the last part. I guess the last part is class. Class is very useful. Actually represents object-oriented programming. So as I said, I copy some of the example from this book. That's that Amazon book. Yeah, so it has nice examples, but of course I'm just covering the basic. Okay, so I think we can finish this in 10 minutes. Let's see how much we have. So 45 here. Okay, up to maybe 60 something, 70 something. Okay. Okay, everyone's doing okay. I hope this is useful. Is it too basic or is it too basic thing that I covered? Okay. So class is very useful. So let's look at example. I mean, we learn by example. So to define class, we say class, the step. Of course, everything you define function, you have to have these column. And you want to initialize an instant in the class. You would need to have a function that help initialize. So this is like double underline, init, double underline, self. You always have to write self. Self refer to the instance. And this is the input variable. That's the three here, the position, name, and pay. So let's just look at how it uses it. So I would say office step 1 is step. This is the position, is the basic, and the name is Cindy, pay is 0. You don't need to write cell, okay, because cell is basically this is a cell. Okay, so but this is how you write it, how you define. So this is the input, right? And then so you would assign that to the internal variable. So there are 3 internal variables here. Position, you get this from here. Name, you get it from p name. Pay, you get it from p pay. Okay, so this define how a class instant will be initiated, and we have 3 variables. It's important to know this is internal variables that belong to when you initialize, right? This office step 1, there are 3 variables. And when you do that, it would also say print. It would print this. Okay. And then you have another, I don't know, you call it this function or property function. String, maybe. So double underline string, str, and double line self. This is when you print, it would print using this. Okay, so below here, I say print office step 1. It would print the way we describe how to print it. Okay, we print the position, self, and pay, name and pay. Okay, I don't know. You call this is initiation, and maybe this is do you call this as property or function? I don't know. It's like a property. Self is a method. You call it method? String. Method. Okay. How you print it? Calculate is a function, but it's a method. I don't know function, a method. Okay, so yeah, this is also a method. As I commented here, a special method to print information about the instance. Okay. So there is a function, this internal function. We also call it method to calculate the pay. So in order to calculate the pay, you need to know how many hours the person worked and what is the rate. So they will input this, and then it will calculate the hour times rate. And once it has that, it would record that into this internal variable pay. Okay, but then it does not keep a record of the hourly rate or hours. Yeah. So next time you do that, you would need to change. You need to input that again. So okay, so that's define. This define a class called step. Okay. So we initialize this. Now we have a step. The basic position. Its name is Cindy. Pay is not assigned 0 because we don't yet have the pay information. You can print this, right? So you can print these. So you can actually access the internal variable by using the class name dot the internal variable. Then you can print them. You can also change the variable. For example, I changed the basic position to manager. So I say this dot position to manager. And if I print this, it will use the string str function method that I assign here. How to print it? It will print the position, name, pay, right? Now I want to calculate the pay. So far the pay is still 0. And if I calculate the pay, okay, I forgot hours, let's say 40 hours. The rate, I guess minimum wage is 15. Okay, so that's 600. And then you can print this again. So the pay will change to that. Okay. Yeah. So as I wrote here, very often we do not want user to directly change the class variable directly. Like you don't want to like just dot and then change. So we will change this. For example, let's just modify the position will modify so it has a underline position. But this is just to signal that it's an internal variable we don't want you to change, but you can still change it. Yeah. Okay, so we modify this. And in order to access this, you write a property, okay, position. This is a getter method. When I say print, when I get position, I will return this underline position. Okay, so I no longer directly use the class that underline position to ask. You could still do that. Just like the other part, we don't enforce that it's the integer. Okay, but it's based on that people would obey the rule. and how you change the value is it's a setter function method. You call it position dot setter, and you say for example here I write this way: if the manager or basic, then you set a value. So here saying that we only have 2 positions, manager or 2 type of position, manager or basic. If it's something else, we will say invalid. Of course, this is like what we said. If you define a function, you need to set a lot of checking. Yeah. Otherwise, wild thing would happen. So basically, we change the position variable so that we don't want the user to directly use cell that position to change it. But you can still use that. That's right. Which one? Here. Underline, yeah. So this is saying that I don't want you to change. Yeah, I don't want user to change. You can still use. You can still say stat that underline position to change that. But you use double underline, then it would not allow you will not be able to change. But there's still other method to directly change. So I guess, yeah, you need to obey the convention. Yeah. Okay, so yeah, everything is still the same. Yeah, except also the print. Yeah, we will need to yeah, so except here, oh, I think here we need to change this. Of course, internal function, you directly access that. But for the user, you don't want to use it. Okay, so we do this again. So when you say that position, now it's not using this, right? You could still use this, the ink. You could still use that. But when we use position, it would switch to this, using this. So here would print extra like getter method. And we could also setter, like setting its value. You could do it here, like you could do underline. Underline is, you could still do that. But the way when you write this is you don't want the user to directly do that. So you could still do this, directly change, but you want the user to use the setter function to change. When you use the setter function, it would allow you to check, right? If you, this is because, yeah, I think here illustrate why you want to do that, because if you arbitrarily set a position that does not exist in the company, that would be weird. So here you allow you to check. Okay. Yeah. So as I said, you could use underline. To avoid this, you can use double underline. So using double underline, when you try to exercise using double underline from outside, it would cause error. But you could still access that because double underline is equivalent to underline step that double underline position. But again, try to, yeah, if you obey the convention, then yeah. If you insist to directly access that variable, is there's still a way. Okay. So this is the class. Any questions? So I think interesting thing is you can, based on the class, you can define a subclass or a child class. Right. I think this is where it's really object oriented. So we can define, so we define staff, right? We can define another class as management staff. And this inherit from existing class staff. So to initialize that, we will still have name, pay, positions. Okay, here we'll have name and pay because it's already management. So we will use the initialization method in the parent class. It already has a manager. So we'll say super is using the initialization in the staff to set manager and pname and ppay. So basically setting those internal variable. Okay, there are three internal variable in the parent class, so they still inherit from that. And additional internal variable in this management class is allowance and bonus. So you set here, and then you can calculate pay. Calculate pay because it's management, so they have bonus on top of the basic pay. And so you would calculate basic pay using the parent method to calculate pay. So when you do that, you will use super bracket that calculate pay to use the function not defined here, but defined in the class that you inherit from. You use this one. This is in the staff class. Okay. So these are calculate pay, and then you would add the allowance, like a bonus. No, allowance. Okay, there's an allowance and bonus, so there are two different things. So you calculate allowance. This is the pay, and then there's also a bonus. This is performance bonus. It does not contain in the regular pay. This is the bonus. So for the management step, you have additional function to calculate what's the bonus. You enter this, so this function, but it depends on the performance, right? So if the grade is A, then you give the bonus. If it's not A, then you won't do that. Okay, so this is a management step that inherit the class step, but you can also define a basic one. The basic one, you will automatically set this as a basic position and use the parent initialization setup. Calculate pay because the basic step does not have additional thing. So use the old function to do that. Okay, so we can do that here. So now we create two steps. Peter is the basic one. There's a name and pay because he's already the basic one, so we don't need to put the basic in the position. The management, just put a name, pay. This is allowance, and that's bonus. You can print them, and it would use the. Let me see. So here we don't write the string. So I think here implicitly it would use the old method in the parent class to print. You would use this position name because it inherited from that. Okay. Now we can calculate pay. So for these two step member, okay, hours for Peter, for example, you can just let's say 35 hours. Rate, say 20, for example. This is for Peter, who is a basic staff. Number hour for John, it's management, let's say management, work just 20 hours. But the rate is higher. What is the rate? Let's say 50, or so it has a higher salary. And performance for John, if let's say it has A, then has a bonus. Okay. So that's basically the stack, and then inherited basic stack and benefits. Yeah, that's almost what I want to say, but there's additional thing. You can check is Office Step 1. Office Step 1 was created a long time ago, right? Using stack. You can ask, is Office Step 1 an instance of the stack class? And we have Office Step 1 created under that. Yeah, here, Cindy, right? So you can say you can check, is that an instance of that class? And it will show it's true. Is office step 1 an instance of management step? No, right? Because it's never created from that. And is John an instance of staff? It is true because it's inherited, even though John was created using management. So is John a management instance of management step? Yes. Is Peter instance of management step? Of course not. It's basic, right? But is Peter? You can also ask, is Peter a step? Oh, we already asked. Yes, right. Is instance, you can ask, is phi instance of flow? Like in the previous, maybe in the previous computing, checking the prime, we could say, is this number instance of integer, right? If not, then we exit the function saying that you're not inputting an integer. You can go back and so you could go back, use this. So let me just put a remark. You can go back and modify and add a checking whether the variable is an integer in check prime function. Okay, so is phi float? No. Is 5.0 float? Yes, right. Is phi, you can just play, we just add code and is phi an instance of integer? Right, you could, is phi an instance of string, for example, right? Okay. This is just checking. This one is a subclass. Is staff a subclass of staff? Well, by definition, you is a subclass of yourself. That's a definition. I mean, you could define it the other way, but is staff a subclass of management staff? No, it's actually the other way around. Right? Management staff is a subclass of staff. Is basic staff a subclass of staff? Yes. The next one is asking, does John has the attribute pay? Does John has attribute calculate pay? Does Peter has a attribute of calculate performance bonus? Peter is the best basic staff, so it does not have that. Okay, so that's the end. I think we learned Python in in 1 hour and 10 minutes. So we achieved it's much better than the book. The book says learn Python in a day. So basically, I summarize the essential things about the content in that book, except I did not talk about file, access file, etc. But most of the content from that book is contained in this current book, which I can use later to teach my son.
How old is
He's 12. Okay, so we have 5 minutes left, so maybe we go to the slides. So I give you a really crash course on Python, which I'm also not an expert, but when you need it, you would just go check documentation or go check previous node or other people's code and then just modify it. Or like you could ask ChatGPT, DeepSeek to help. Yeah, because we use that as a tool. Okay, so I want to okay, Penny, then we go maybe come back later. I don't think for this class I need to review this. So basic principle, superposition, unitary measurement. Actually, we use this. This is actually a slide from high school chem, probably. At least 3 of you recognize that. And I also talk about superposition, can be used to seems to provide computational power, but of course there's measurement, right? So we learned this in class. And you remember Deutsch algorithm? It's a binary function of one variable. There are four possible functions, right? But you can divide into two, constant and balance. Constant means all the same. It doesn't matter 0, 1. These are constant and these are balanced, right? Right. So this addition is mod 2. Okay. So the question is, can we decide whether the functions are balanced or constant without evaluating all the two cases? So this is equivalent to computing the addition of these two numbers. Is this 0 or 1? Right. You remember this, right? This is the simplest quantum algorithm one has need to know. Yeah. If you don't go back to that. And we use the phase kickback trick to analyze. But at the end, the algorithm is that you send in plus and minus, and then just measure this one to see if it's a plus or minus. Okay. If it's plus, then it's constant, minus is balanced. Okay. Yeah. So we're going to see an example. I have a notebook. You can download. But let's ask a question. How do we? I think it's in your homework. How do we implement this? So this would be something that would add F to that. How do we design the circuit to implement F1 equal to 0? It's easy. You do nothing. Right? F1 is 0, so it does not add 0. Does not do anything. F1 is easy, right? What about F2? F2 is need to add 1. So you would have a X gate, right? Add 1 is X gate. Okay, what about F4? This is what circuit do we need to use? 0 is 0. 0, it does not do nothing. 1, it would add 1. Yeah, CNOT gate, right? CNOT gate. So what you could do is, of course, I was, let's see, maybe, you could do things. We are going to use Python, but you could also use Quantum Composer. Let's just quickly go to Quantum Composer. You could also play along. Go to Quantum Composer and do that. Okay, Quantum Composer. Here we are. Okay, this is the circuit that my daughter dragged last night. She said she want to play. I'm going to create another one. Somehow they like to play with my laptop. So they said, "What's this?" And then she dragged all these gates. So what we have here, we have more qubit than we want. So we need to delete it. Okay. And this is the classical bit. Actually, classical bit, we only need one because we're going to measure one. So the plus state is using Hadamard, right? You could also the minus state is using NOT. This is NOT, and then you do the Hadamard. Okay. You could also use Hadamard and Z because the identity in the gate. Here I'm just putting these dash line. I just wanted the circuit to look nice, so I put an identity here. Dash line is a barrier, okay? Just this is like initialization, this is plus. And if my function is f4, I'm doing these control now, right? Okay, then I do the measurement, okay, but let me just separate so that this is inside. Here is the oracle that give me the function, but I should not know the function. You know the function. So Sina, is this a balance or constant? Balance, right? Because 0 it was 0, 1 is 1. To the measurement, you would measure here in the x basis, but we don't have measurement in x. We need to convert to using Hadamard, right? And let's do the measurement. Let's do the measurement. The measurement is this. We do measurement on the first. Yeah. So you see the measurement giving you 1. That's this means that it's a balance, right? You could remove this, then will be a constant. That'd be 0. Okay. So I want to go to the notebook. You have that in. Just quickly, maybe we will explain more next time. So this is the Deutsch algorithm. So I now hide the 4 functions. It's called secret function. It randomly generates 0, 1. Okay. So it's a list of 0 and 1. And I define this oracle. And depending on the secret function, I have these control na, x, etc. Right. This would allow me to generate those 4 functions. Of course, if you print the secret function, you know what that is. Then I write the Deutsch algorithm circuit. I have 2 quantum bit, 1 classical bit because I only need to measure. And this is what I just did, right? Hadamard 0, x1, Hadamard 1, I draw a barrier. I append the oracle that I would write here, and then I do the measurement. Return the circuit. This is the circuit, right? It's just like what I have in the composer, but now I hide the oracle. When I show you the circuit, it does not show you. It just show you the oracle and the Hadamard measurement. Okay, so we come back next time. So, okay, any questions?